And also you have to remember, I think now I am audible. Okay. Someone has, okay. And also you have to remember there is a term called coefficient of rolling resistance. Okay, there is a term called coefficient of rolling resistance. That is a ratio of rolling resistance to the normal load on the tire. Okay, so that is called the coefficient of rolling resistance. That is when you are going to put a ratio, rolling resistance to the normal load on the tire will be what? Coefficient of rolling resistance. And other factors we will be discussing about this rolling resistance of the tire. That is when you are having a thicker thread. That is, thread is a portion which is going to touch the ground. So when you are having a thicker thread and side walls and increased number of cross play, okay, that is, we are having a number of plays that is united together, that will be giving a tire structure. So when you are going to have this number as increased and your side wall also will be thickened, means what will happen? The rolling resistance will increase. Okay, the reason is hysteresis losses will increase. The concept is whenever hysteresis losses is less, the rolling resistance will be less. Whenever hysteresis losses is going to be increased, the rolling resistance will be more. Okay, and we are going to discuss about the tire material. So this also you can go through. That is when you are having a synthetic rubber, will be having high rolling resistance than natural rubber. And you can see some tires will be made up of a material called butyl rubber. Okay, so that will be having a better traction and road holding abilities. Okay, but the major thing is rolling resistance will be more. One criteria, it is somewhat demerit is there, but in regarding road holding and traction, we'll be having the positive factor. Okay, and you can see in synthetic rubber, that is rolling resistance of the tire, comparing synthetic rubber and butyl rubber, the value is given. See, for synthetic rubber you can see the value is 1.06, whereas butyl rubber it is 1.35. Okay, that is they are comparing with natural rubber. That is when natural rubber I'm having a rolling resistance as 1, my synthetic rubber will be 1.06 times. So approximately it is more or less same when I'm going to use natural rubber. Whereas when I'm going for butyl rubber, my rolling resistance is getting increased, okay, by 35 percentage. Okay, so this also you have to understand that fact. Next, I'm going to discuss about surface condition. Already I have discussed, it seems. Okay. Next, we'll be discussing about driving speed. That is what will happen when you are going to increase the driving speed. Okay. So what will happen when you are having a driving speed increase? That is when you are driving at high speed. What will happen? So there will be an increase of work in deforming the tire, and there will be a vibration. These are the two things will be arising due to increase in the speed. Okay, so what will happen? There will be a threshold speed. Okay, so over this speed, a standing wave will be created. That is, you can see in the sketch. See, a standing wave. That is when you are traveling at high speed, your tire will be deflected, but after some time it should regain its original position. So under this certain condition, it will not be regaining its original position. There will be a permanent, there will be a deformation in the tire. So that is called standing wave. Okay, so what happens when I'm going to exceed a speed, that is when I'm going beyond a threshold speed, the standing wave condition will be acquired. So the standing wave is going to come due to high speed. Okay, so the tire will not recover immediately. That is, the tire will be deflected. Actually, when it is deflected, it will be getting its original position immediately. Then only the rolling resistance will not come into picture. Okay, when it's not recovering immediately, the rolling resistance will be increasing. Okay, so that is the main thing you have to understand. So the deformation is shown as a wave. That is, you can see in the sketch. The deformation is shown as a sketch. Okay. So what will happen? How the deformation will be going out? No, that will be going out in a exponential manner. Okay. So you can see in the sketch, the amplitude of the deformation will be more immediately after the contact patch region. Immediately after contact patch region. Okay. So immediately after contact patch, the magnitude will be more. And what will happen when the standing wave, the amplitude is going to increase? What will happen? The hysteresis losses is getting increased, so it may result in tire failure also. Okay, the standing wave phenomena. The standing wave will be coming only at high speed. Okay. Next, we are going to see about temperature. That is, what is the temperature of air in the tire. So how it will be affecting the rolling resistance. Okay. So all the parameters which is going to affect the rolling resistance, we are going to discuss. So you can see how it will be affecting. That is, temperature will be influencing the stiffness. It will be changing the stiffness and hysteresis. The hysteresis property is influenced by the temperature. Okay, so you have to remember that is the temperature at minus 10 degrees Celsius. My rolling resistance is approximately 2.3 times at 60 degree. So you have to remember this fact. See the temperature range, how it is influencing the rolling resistance. Minus 10, the rolling resistance will be increased the same condition of the tire at temperature at 60 degree. Okay, so you have to remember the reason is when you are having that temperature change, it will change the stiffness and it will be changing the hysteresis losses also. Okay, so it will be affecting both the parameters. So my rolling resistance is getting increased at lower temperature. Okay, then I am going to explain about diameter. So it will be a very less effect only, but when I are going for hard surface, say when I am going to travel on a standard highway, the effect of diameter will be less. If I'm going to travel on a deformal road, that is a ground, say mud or something, then tire diameter comes into the influence of rolling resistance. Okay, then we are going to compare the truck tire and passenger car tires. You can see the truck tire, the rolling resistance coefficient will be lower than passenger car. Why you may think the truck tire size is more, the rolling resistance will be more, but actually the rolling resistance coefficient of truck tire is lower than that of passenger car tire on road surface. Why no? In trucks, you'll be going for high inflation pressure, or passenger car lower inflation pressure. So high inflation pressure means the hysteresis losses will be less, whereas the low inflation pressure means the hysteresis losses will be more. So in the meantime, you go with the tire pressure in trucks. That is, you can see in trucks you'll be having 90 to 120 psi. Okay, whereas in passenger car you can see 28 to 336 psi. Okay. Next, we are going to discuss about cornering property of the tire. So you can see that is whenever I'm using the word tire, I can use the word pneumatic tire because the tire is filled with air. Okay. So what happens when I'm going to take a turn or any side force is going to act? I have to study about my cornering properties of the tire. That is, you can see a pneumatic tire. If the force is not acting in the plane, okay, that is a perpendicular to the wheel plane. So this is the wheel plane, the side force will be acting. You see my cursor movement. So if this force is not there, the tire will be moving along the wheel plane. Okay, there will be no slip angle and nothing. It will be following the wheel plane. So when the side force is going to happen, listen carefully. The side force will be acting on the tire. In order to counteract the side force, there will be another lateral force. Okay, so it will be developed due to the contact maintained with the tire with the road. Okay, so a lateral force will be developed at the contact patch. You can see both will be in opposite direction. Okay, so due to this, what will happen? The tire will not be moving along the wheel plane. It will be deviating from that plane. That the angle is called slip angle. Let me show the sketch in a zoomed view. See, this one is the tire. That is, you can see in the front view. What happens at the center? We are having what? A side force is going to act. Okay, and due to in order to counteract the side force, due to the contact of the tire with the ground, a lateral force is going to act. So Fs stands for side force, the force which is coming externally, and Fy is the lateral force due to the properties of the tire, due to the cornering properties of the tire. Otherwise, I can say cornering stiffness of the tire. Okay, so due to that property, I will be having a force to maintain the tire in the original position. So for that force, we are using what? F suffix y alpha. Okay, F suffix y alpha. So what happens now? Instead of moving in the straight ahead position, there is you can see the center line. The tire will be moving along a path OA. So it's getting deviated from that path. So that angle where the tire is moving, where it has to move, so that angle is known as slip angle. Okay, so that angle is known as slip angle. Okay, so you have to remember this sketch for understanding slip angle. Okay, so the tire will be moved along a path making an angle with wheel plane. Okay, actual path of the tire making an angle with the wheel plane. That angle is known as side slip angle. Otherwise, I can say slip angle. And I can say this term as side slip because the tire is getting a slip in side direction. Okay, side slip. And mainly why it is coming no due to lateral elasticity of the tire. This is elastic property. So elastic property, whenever force is going to get acted, it will deform. So due to this only we are getting what? Slip. That is, if we get any question, lateral elasticity of the tire. Okay. Now we'll be discussing about this. See, I told no the lateral force. Okay. So the lateral force, that is Fy alpha, that is developed at the contact patch. You have to remember the word. The force which is acting at the center will be the side force. The force which is acting at the contact patch is called cornering force. Okay, so you can see the lateral force which is acting at the tire ground contact patch. Okay, so the name of that force is called cornering force. Okay, and you have to remember this condition, that is when the cornering force is, we are going to say the cornering force, camper angle of the wheel is 0. Assume that camper angle of the wheel is 0. Under that condition only, the lateral force developed at the tire ground contact patch will be called as cornering force. And you have to remember, that is, you have to study the relation between this cornering force and the slip angle. That is, when there is a more slip, a slip angle is getting increased, what will happen to the cornering force? So that when you are understanding the relation between cornering force and slip angle, you will be knowing about, that is, you can examine the vehicle maneuver, that is a directional stability of the vehicle. You can know whether you can say the vehicle is stable or not. It is whether it is under your control, that is, if you want to turn something, it is doing handling. So everything will be decided by studying the relationship between cornering force and slip angle. Okay. And the main thing you have to understand is, okay, there is a see in the sketch, the tire is going to move in an angle that is in the path OA. It is having the slip angle. So what he is saying, that is the tire is going to moving at a uniform speed. That is, it is not going in the straight ahead position. It is going in OA. Okay. So what happened? The side force that is at the center now, and cornering force at the ground plane will not be collinear. Line of action will not be same. Okay. So you have to remember this. Okay. Collinear means the line of action will not be same. That is when I am going to travel along this path OA. So the two forces are going to act. That is Fs and Fy. It is not collinear. Okay. So depending upon the slip angle, the cornering force position will be varied. So you can see when the slip angle is small, it will be behind the side force. That is, you can see my cornering force will be behind the side force. Okay. So what will happen? The force magnitude will be same, but separated by a distance will give what, a couple or torque. Okay. So you can see, due to this, I will be getting a couple or torque that can be termed as a aligning moment. So due to the cornering property of the tire only, when you are making a turn, due to this cornering force develop, the tire will come to its original path. So you have to remember this. So the moment which is going to assist the tire to come to the original position is called what? Aligning torque or self-aligning torque. And why it is coming? Due to the lateral elasticity of the tire, due to the cornering property of the tire. Otherwise, you can say due to the cornering force acting at the contact between tire and ground. Okay. So a couple or torque will be formed. And that couple or torque, the name is self-aligning torque. I can use, or aligning torque. Okay. So it is a restoring torque. It will bring the steered wheel to the original position. Once you are completing that turn, that is, after completing the turn, the tire will again come to the original path. That is, it will be traveling along the straight ahead position. So no side force will be acting, and slip angle also will not be there once it is coming to the original position. Okay. And in the sketch, you can see the distance between the side force and this cornering force. So this one is a top view. Only in top view you can see this slip angle. That is, you can see how far it is getting deflected from the vertical. So in this sketch, you can see the distance between Fs and Fy alpha. That is a cornering property. There is a cornering force. It's not collinear. Okay. So we are having some distance. So that distance is called pneumatic trial. So you have to understand the distance between Fs and Fy alpha. This distance is known as pneumatic trial. Okay, pneumatic trial. Okay. So distance between the side force and cornering force is called pneumatic trial. And when you are going to multiply the cornering force and the pneumatic trial, that will be the determining the self-aligning torque. Okay. So you can see in trucks, the pneumatic trial will be more. So we'll be getting more self-aligning torque. So depending upon the load, what will happen? The tire requires that self-aligning torque to bring back to the original position. Okay. So a question can be asked. A question, a wording can be given. Cornering force. What is the cornering force? That value will be given. So it's an application-oriented question. No? They may ask you self-aligning torque, determine the self-aligning torque. So you can refer this concept and refer this formula, and you can what is necessary. That is, you have to understand the cornering force and side force will be more or less equal. Then only we'll be getting a coupler torque. And when we are going to multiply this cornering force with the pneumatic trial, we'll be getting what? Self-aligning torque. So I'll be giving 2 minutes time. So you write this formula. You write self-aligning torque is equal to cornering force into pneumatic trial. Okay, and you copy this sketch also. First you write the formula. Okay, first you copy this sketch. For just put a rectangle, show that Fs and cornering force. Then you write self-aligning torque is equal to cornering force multiplied by pneumatic time. Okay, I'm giving a 2 minutes time. Copy the sketch. Then only you'll be familiar with the terms. Okay. Please copy it, ma. After copying this sketch, write this formula. Okay. Next, you can see this is a very important curve. That is, in if it is a conventional exam, you should be practicing this sketch. See, the indication is very easier, because you have to understand the end result only for current exam scenario. But in previous conventional mode, you should be able to draw the sketch. So you can see, this is the cornering force characteristics. That is the cornering force versus slip angle. I am plotting a curve. Slip angle in a degree, see 0, 4 degree, 8, 10, like that it is going. Okay. Cornering force, we are having, forget about this pound, Newton, 1000. So he's taking two tire, radial tire, bias play. Radial tire, the plies will be running in radial direction. Bias play, it will be, the plies are woven one over another. It will be having a ply angle. So you can see, with increase in slip angle, the cornering force will be increasing in a greater trend compared to radial tire. Okay, say for radial tire compared to bias plate tire. So the increase in cornering force will be more for a radial tire compared to bias plate tire for increase in slip angle. Okay, that is the main observation of this characteristics. Okay, so this one you have to understand how the slip angle is going to influence the cornering force. For this slip angle, what will be the cornering force I am going to get? And you have to understand, slip angle only is going to decide the cornering force. If more slip angle means what? I'm using the more lateral elasticity of the tire. That tire property, cornering force will be more in order to overcome that side force. So it means what? Slip angle more means I am compelling my tire to give more force. That is, I am compelling the lateral elasticity of the tire to give more force. That is a cornering force. So you can see it is getting increased with the slip angle. Okay. So up to a particular limit only, the tire will be able to provide a increased cornering force. After that, it will be getting saturated. Okay. So you can see the road adhesion limit. So before that only, I can provide the maximum cornering force. That is, you can see the linear characteristics. That is, you can see up to 4 degree. The relationship between cornering force and slip angle is almost linear. You can't say 100% linear, almost linear. And after that, what happens? No, you can see here. You can see slip angle is increasing means cornering force also will be increasing in the same fashion. But after 4 degree, the slip angle is going to increase more. The cornering force is not increasing more. It is not following the trend of increase in slip angle. It is not proportional to increase in the slip angle. Okay. So what we can say, the cornering force is increasing at lower rate. Okay. It is not increasing at a rate proportional to the increase of slip angle. Okay. So after that, it will be reaching the maximum value. So there will be a lateral sliding of tire. The tire going to move in lateral direction. What does it mean? No? If cornering force provided is not sufficient to meet my side force, my tire will be moving in lateral direction. It will be sliding. It will be caught. It will be leading to tire scrubbing or rubbing of the tire. We can use the word like this. Okay. So you can see for passenger car tire, no, the maximum cornering force will be occurring at a slip angle of about 18. You can see about 18 degree. That is, I will be showing another sketch. This is for roads. Okay, for that graph is not there, but you note down this value. Okay, that is for passenger car tire. No, the maximum cornering force will be I will be getting it at a slip angle of about 18 degrees. Okay, and for racing tires, the cornering force will be 6 degrees. Okay, and you can see bias plate tire, the cornering force increase will be less with increase of slip angle. Okay, So you may ask, what is the desired characteristics? See, I can prefer this characteristics for two-wheeled vehicle. That is for motor cycle. No, I can go ahead with this bias play. That is, my cornering force will be increasing slightly. The increase will be less with slip angle compared to radial tire, because in a two-wheeler I have to avoid that lateral sliding of the tires. Okay, so I prefer the increase in cornering force should be less with my slip angle. Okay, so in two wheeler, based on that orientation, that is a, we are going to provide a balancing with balancing will be done by us. So considering that, I can go for this bias play tire. Okay, so that will be more suited for two-wheeled. That is two-wheeled vehicle. I will increase. I will prefer a gradual increase in cornering force with the slip angle. I will not prefer for what more increase in cornering force. Okay, so this will lead to some stability problem, or it may lead to some tire wear or other factors. So you have to study about that. That is when you are going to fit a radial plate tire. So you have to understand what are the drawbacks, and when you are going to put bias play, how the drawbacks are going to be getting overcome. So based on that experimental study, what they are telling is bias play is preferred, because a two-wheeler, it require what, a gradual increase in cornering force. So then only we'll be having a better control. Otherwise, you'll be losing the control and you'll be falling on the ground, or other negative factors will coming into the picture. Okay. So you remember this fact. Bias plate tires are used for motor cycles. And you can see in the next curve, I'm going to compare the same cornering force characteristics with slip angle. You can see the radial rib and lug and bias rib and lug. That is, I am going to include the radial tire and bias play with rib also. Okay, there is this graph has been plotted. That is when I'm going to drive this vehicle on a concrete road. The speed is given. Okay, and you can see this curve. That is for a different slip angle. So here, instead of plotting a cornering force with the slip angle, I think let me zoom it again. I think now it will be more visible. For exam, you no need to draw the curve just to understand what is going to happen. It is this in this characteristics. Now, what I am going to explain, I am plotting a curve, cornering force versus normal load. Normal load means what is the load acting in vertical direction, weight acting on the tire. For different slip angle, you can see 1, 2, 4, 8 like this. Okay, so how the cornering force is going to get vary with the normal load. Okay, you can see the slip angle 20. You can see the variation pattern, and this has been tested at a rated speed, say 30. Okay, and what is the pressure and everything should be mentioned. That is when you are going to make a test, the input, what are the parameter constant, no, you have to mention. So this curve, no, that is what I have shown. It is going to explain you what is my effect of normal load on cornering characteristics of the tire. Okay, that is when normal load is going to get increased. You can see the cornering force also will be increased, and it will be linear at a larger slip angle. Okay, so that is the inference. That is correlating cornering force with normal load with slip angle. Okay, so you can see here the another sketch. That is, he is discussing about the load transfer. What will happen when the load transfer is going to happen? That will, how it will be influencing the cornering force. Okay, so you can see when the load transfer is going to happen, the cornering force is getting reduced. Okay, so you go through this sketch, you'll be able to understand. The explanation is given in the next slide. Okay. So you can see how the normal load, the explanation is given here. how the normal load is going to affect my cornering force. That is, I can say for a given slip angle, the cornering force will increase with increase of normal load. Already I have told you in the graph. And you can see it is almost non-linear. You can see for a different slip angle, it's almost non-linear. Okay. And you can see in this curve, that is how the transfer of load is going to affect the cornering force. That is when I'm going to make a turn. Okay, you can see in the sketch the load on outer tire and the inner tire. That is when I'm going to make a turn. What will happen? The load will be transferred from the inside to the outside. Okay, so when I'm going to wait for a minute, sir. Mechanical. Okay. So now you can see when I'm going to turn, what will happen? The load will be transferred from inside to outside. Okay. So this will reduce the total cornering force. So that also we have discussed. There is for explaining this. Let me zoom this sketch. Then only you'll be able to understand. Wait for a minute. Okay. Now you can see this curve. See this curve alone. What happens? So he is measuring the cornering force. Okay, so due to the load transfer, you can see the cornering force is getting reduced. Okay, that is, you can see in x-axis we are having normal load. So when normal load is more, I will be having a cornering force in this value. When it's getting reduced, you can see the cornering force also is getting reduced. So the reduction, I can measure it in this fashion. So you can see that is you are having an axle. Okay, so both is having a normal load. Okay, so this one is FZ. FZ is uh, each tire is having a normal load FZ. That is when the tires are moving in a straight ahead position, FZ will be acting on both the tires. Okay, so now what will happen to this cornering force? No, is Fy. That is mentioned. See Fy. In order to make it clear, when the vehicle is making a straight ahead position, when moving in a straight ahead position, let us say the normal load is Fz, my cornering force is Fy. Okay, so the cornering force per tire, always you will say cornering force for a single tire, not for two tires. So the cornering force per tire with the normal load Fz, it will be Fy, and it is for a given slip. And when I'm going to make a turn, that is always, when a turn is made, there will be a lateral load transfer. Lateral load transfer means at one wheel the load will be reduced, whereas in another wheel the load will be increased. Okay, So we can say lateral load transfer will affect the cornering force. So you can see now, this one is inner tire. Okay, when I'm going to make a turn like this, say left turn, see left turn, inner tire, outer tire. So you can see inner tire, this normal load will get reduced, and outer tire, the normal load is getting increased. Okay, so previously it is FZ, now it is getting increased to decreased to FZI. That is inner tire, the load is getting decreased to FZI, and outer tire, you can see outer tire compared to FZ, it is getting increased to FZO. Okay, so FZO. So now what happens now? Previously, the normal load FZ is same for both the tire. When it is going to get turned, the normal force distribution is getting changed. Inner tire is less, outer tire is more. Okay, so now what happens, the cornering force, that is for, if I'm going to say the cornering force, if the what cornering force for this tire and this tire, when I'm going to add, listen carefully, that is for this tire I'm going to add, I'm going to find one cornering force, and this tire I'm going to add this cornering force. When I'm going to add the two cornering force, it should be equal to the cornering force of FZ. In other words, in the normal condition I'm getting corner force, say Fy. Under turn, inner tire I will be having one cornering force, outer tire I will be having cornering force. When I'm going to add, no, it should be same as that of Fy, but in actual scenario it is not going to be happen. So you can see the total cornering force will be sum of Fy and F naught, which will be less than 2Fy. Why is saying a 2Fy? Because this Fy is for one tire. When I'm going to consider two tire, it will be 2Fy, because the normal force is same. The cornering force also will be same for both the tire. Considering both the tire, I will say 2Fy. So this is the main content you have to understand. That is individually, when it's going in the straight path, the normal force is same, and cornering force I will be getting the Fy. Adding both, I will be getting 2Fy. But when I'm going to make a turn, the cornering force is getting reduced. So when the reduction will be what? FZI and FZO. But when I'm going to add the cornering force, actually it should be same, because one end it is getting a decrease and other end is getting increased. So when I'm going to add, it should be same as that of previous condition, but it's not happening. So when I'm going to take a turn, the cornering force what I'm going to get, no, for two tires, it will be less than that of the two tires when it's going to travel in the straight ahead position. So that is the conclusion. Okay. Let me delete that sketch so you can see. So what we can say, that is we are having a pair of tires on an axle. So it will be developing the required amount of cornering force. Okay. So in when I'm going to make a turn, see what does it indicate? No, clearly I understood this concept, ma. Why there is a reduction in cornering force? Because some amount of force have been gone to balance that centrifugal force during a turn. That force together with centrifugal force will bring the self-aligning torque and will bring back the tire to the original position. So some amount of cornering force have been gone to produce a self-aligning torque. Okay, so that only what happened when I'm going to add the two cornering force, it is not equal. So some amount of force is gone to balance the given centrifugal force to a turn. So the lateral load transfer increase in slip angle of the tire. Okay, so you have to understand that is this concept is when I'm making a turn, the cornering force which is in the real condition, adding the two tires will be less when it is going to happen in the straight ahead position, and also when I'm making a turn, there will be the lateral load transfer, and it will result in slip angle. We'll be getting slip angle. Okay. And next you have to understand that parameter. This is very, very important. That is, I told you, no. Let me show this sketch. So this one is what? Cornering force versus slip angle. So when you are going to find a slope for this curve, no, it will be stiffness. That is, you may plot a curve x versus y. Slope will be, if it is a linear, will be having a slope. Okay, so similar to this, cornering force is going to vary with the slip angle. When you are going to find the slope of this curve, it will be what? Cornering stiffness. So I can ask one question. That is, they are told, the application. So I will be putting this curve, and I will be asking you to find from this curve, find the cornering stiffness of the tire. So what you have to do? You have to take 2 points from this curve, and you have to find the slope, and that slope will be the cornering stiffness. For understanding this, no, you have to be familiar with the concept. Okay, that is on the spot you can't refer this. The test what the university is going to plan, no, that is a 1 hour test. There you'll be having, it seems, 1 hour or 2 hours, whatever it may be. On the spot, the student who didn't gone through the book from the initial days, only on the time of exam is going to open. Okay, he can't grasp this topic. That is, he can't study, and he can't understand the slope of this curve will be the cornering stiffness. Okay, because he will not having time. He can. You should be knowing all the facts. He can refer the book for formula. Okay, he may have some doubt. That is the slope of this curve, cornering force versus slip angle will be cornering stiffness or lateral stiffness. So like that, you may have doubt. That doubt can be cleared by referring that book or material. Okay. So when he doesn't know about this fact, no, it will be taking more time. You have to go through all the topics, and it will be taking more time to answer one question. So when you are attending that online exam with open book, all the facts you have to know, whether you are knowing the formula or not. All the facts you have to know, and in which page it is coming, and how to trace it, and how to get the information, how to make the data interpretation, everything you should know. Then only you can take this exam. It's actually is a very new. How to have this mock exam, I don't know how they are going to conduct. And I am also searching for some model questions. Let us discuss with some experts. Okay, so that we will be framing this question paper. Let us see in net. So how the open book exam question paper will be there for the subject, and we have to examine. Then only you can prefer for the exam. Okay. For time being, you no need to bother about anything. Refer the syllabus, study all the contents, but no need to remember anything. That is, remember means no need to mug up the formulas. Just understand the concept. That will be sufficient. If I am going to ask a question, you can take a book and you can say, sir, cornering stiffness will be the slope of this cornering force versus slip angle. So in that manner, you have to prepare, and you have to get it within a short duration, say 3 or 4 minutes. So you have to refer, and you can highlight this formula. Okay. So in that manner, you have to study. Then only you can attend that open book exam. Okay? And there is another property. You can see what will happen with the normal load. Okay. That is, I am not going to consider the slip angle variation, and I'm going to study what is the effect of normal load on cornering force. Okay. So cornering coefficient already you know. Cornering coefficient already I have taught you. That is a cornering force by normal load. Okay. I think I might have highlighted. Okay. Okay, you listen. Cornering coefficient means cornering force divided by normal load. Okay. So when it's going to get decreased means cornering force is getting decreased. So already I told you in vehicle dynamics, instead of going with the force value, I can go ahead with the coefficient so that I can easily plot the. So here also is saying what? Percentage normal load, that is increase in normal load. Okay. So here the definition is there. What is cornering coefficient? Cornering stiffness per normal load. Okay. So when the cornering coefficient is getting decreased, I can say cornering stiffness is getting decreased. So when percentage of normal load is getting increased, 50% increase in load, 100% increase in load, you can see cornering coefficient is getting decreased. Okay. And you can see the countering coefficient influence with the inflation pressure. That is, whenever you are having more inflation pressure, we have discussed about the rolling resistance, and now we will be discussing about the countering coefficient. Okay, so you can see it is getting increased, and we are having three tires. Okay, radial tire, bias plate, and other thing. Okay, so the effect of inflation pressure on countering coefficient is not much significant. It will be less, and the countering stiffness we can say it will be increasing with increase of inflation pressure. So this curve shows what three different tires, and this curve, no, it is combined curve. It is like a lattice plot. That is, you are having a countering force, self-aligning torque, and you are having slip angle. So I can any two values are known. That is, if I know self-aligning torque and the countering force, I can go get which slip angle it will be having. Okay, if I know slip angle and self-aligning torque, I can find countering force. So it is a graph denoting the relationship between all the three factors, that is countering force, self-aligning torque, and what slip angle. Okay. And this one you can see self-aligning torque and slip angle. Normally you might have seen countering forces with slip angle. This one is slip angle versus self-aligning torque. Okay, so and normal load also it is included. So y-axis self-aligning torque, and normal load will be in you can see in this value different curves. There is horizontal curves represent what normal load, and vertical curves represent slip angle. Okay, so you can see the variation of aligning torque with slip angle and normal load, and this is for bias plate and radial plate tire also. So we can see with the normal load. Okay, there is a you can see the normal load how much it is getting increased. Okay. So you can see with the normal load, there is you take one curve. With this normal load, the aligning torque is getting increased with increase of slip angle. That is, you can see 1, 2, 4. After that, it is getting a decrease. It reaches a maximum. After that, it is decreased. The reason is what? What will happen? To up to a maximum extent only, I can produce the self-aligning torque. After that, greater slip angle will got what? Sliding of thread. Okay, so I can't have a proper countering force. There will be a sliding, so that my countering force will get decreased. So the self-aligning torque also will get decreased. Okay, so this will be the summary. After this, next class we'll be discussing the camper and camper thrust. So this you please note down. The driving torque, effect of driving torque will be increasing the aligning torque for a given slip angle, whereas braking torque opposite effect. Note down this. That is when I'm having a driving torque, no, when I'm going to make a turn, the driving torque will assist me to increase my aligning torque. But in braking torque, the scenario will be different. And inflation pressure and normal load will be having only little effect, noticeable effect, because they are going to affect the contact patch area. Based on the contact patch only, I am going to get the countering force, and countering force is only going to decide the aligning torque. Okay, and higher normal load and lower inflation pressure. This one note down. Longer tire contact length, so pneumatic trail will be more, so aligning torque will be more. That is when you need more aligning torque, the preferred condition is normal load will be more, and pressure also should be low. So we'll be getting what? More pneumatic trail. That is a longer pneumatic trail. Okay. So with this, we can wind up this class. In next class, we'll be studying the remaining portion. Okay. So by this weekend, we'll be completing this unit, and we can now proceed with next unit the next week. Okay. Because now it is not objective also. Each and every topic you have to understand. Okay. For your senior, it is objective, but for you, The evaluation is totally different. So we have to study like conventional. Okay, you have to study entire thing. You have to study like conventional. Only one relaxation. What you can do? You can refer formulas, sketch, but you should not refer the definition. If I'm asking, no, cornering force coefficient means at the time you should not sit and refer the notebook. What is cornering force coefficient? Cornering force coefficient is equal to cornering force divided by normal load. So that fact and all should be in your mind, so that only immediately you can get the answer. You can the time you can save, and you can answer more, and you can get a pass mark as well as a good grade. Okay, so really it will be a new and a challenging task for you in open book exam. So some of the facts you have to know. You can't sit blindly in the exam. You have to prepare, and no need to mug up. The concept is to avoid students to mug up. You have to remember all the facts. Okay. Okay. Any doubts you can ask? Otherwise, you can wind up this class now.